Hi everybody, welcome to another lab session. In today's tutorial, we are going to learn how to do visualization in Python. So the first thing is to find the script for today. So the script for today is in the OO Business 302 Live, Lab 06. So there are two scripts we are going to go over today. The first one is Lab 00VIZ, and the second one is Lab 01VIZ. And we will start from the Lab 00VIZ. So like before, we first need to import some important libraries like NumPy, Pandas, Matplotlib, and Seaborn. And the data set we'll use is the baby's birth data set. If we check the head of this data, we can see that this data records baby's weight, some and other information like mother's age of marriage, the height and the pregnancy weight, and if their mother is a smoker or not. And the shape of the data is we have 1174 rows with 6 columns. So the first visualization we're going to learn is the bar plot. So the easiest way to plot the bar plot is to use this dot plot function and put the kind equal to bar. And the thing that before the plot is the column of data that you want to plot with the value count function. So if you count the value of this smoker column, you will see that there are 715 mother, they are not smoker, and 459 they are smoker. And after that, we use the plot connects the bar to plot the bar plot, and then you will see that we got a bar plot with the false and true. An alternative way to use the bar plot is to use the Seaborn package. The Seaborn dot count plot and put the data, which is the x equal to the birth smoker, and then we can find we can plot a beautiful bar plot with the Seaborn function, Seaborn package. And then let's move on to how can we plot the data without any pandas difference, which is the list. So here we have 4 majors in the list: data science, history, biology, and business. And we record their GPA with these 4 values. And then we want to make a bar plot for these 2 lists. And we can simply use this plt.bar and put the list of values inside, and then we can plot the bar plot for these 4 majors. Similarly, in the Seaborn package, we have the bar plot function, and with the x equal to major and y equal to gaps, and then we can get a beautiful bar plot by Seaborn. And then let's move on to the ROC plot. And the data we want to use for the ROC plot is the burst weight. We can check our data by print the burst weight. And then use seaborn.ROC plot, put the data inside. And then we get the ROC plot. So basically the ROC plot records how many observations between different range. For example, if there are 20 observations between 100 and 120, then there will be 20 observations here in the middle. So basically it records how many observations between different range. And then let's move on to the histogram. So the easiest way to plot a histogram is to use plt.hist and put the data inside. Then we can get a histogram of the burst weight. We can also use the min and max to calculate this burst weights min and max value. And if you want to change the number of bin, we can create a list of numbers by this range function. So here it means this bins starts from 50 to 200 and the step is 5. And after that, we can change our bin size compared to the original one. And this EC here stands for the age color. And if we change it to red, then you can see the age color of our histogram is red now. And if we want to plot the density function of our data, we can put this density to true. And then you will see now the y-axis becomes the percentage number instead of value count. And you can also see that after we change the age color to W, then the age becomes the white color. And the alternative way to draw a histogram is to use the data first and then dot plot to the kindest hist and keep the rest the same. We can also make a histogram. And then let's try to change the number of bins. We can see that if we decrease number of bins, then our data has less bar. And and if we keep decrease the number of bins, we can have now we only have 4 ranges, 4 bins. Right, so let's move on to the density curve. So density curve, in the seaborn, we call it the KDE. So that means, so the density curve or KDE means that we draw a line of our data, and it's very similar to the histogram. So to do that, we use seaborn.kde plot and put the data in. So this is the density curve or KDE line. And if you want to use the seaborne, if you want to plot the KDE line and the histogram at the same time, then you can use the seaborne dot histplot. Put the data in and at the same time give the keyword KDE equal to true. And then we can see that we have this line and the histogram at the same time. And also, if we also want to see the rug plot at the same time, we can put the three together by giving another keyword argument rug equal to true. But if we only want to see the KDE and the rug, and I don't want to see the histogram, then we can use the list plot. This plot and put the birth weight of the data inside. The kind is KDE and rug is true. So in this scenario, there will not be any histogram. We only can see the KDE line and the rug. Okay, and let's move on to the box plot. So to draw a box plot, we use the seaborne dot box plot function and put the data. This y means the what kind of data you want. So y is equal to the birth weight. And you can always change the fig size with this plt dot figure. And fig size to 3, 6 means we want the side of the x-axis is 3, and I want the side of the y-axis the 6. So you can change whatever side you want. So inside of this box plot, there are a few things to say. So here we can first look at the middle line. So the middle line is the median of the data, or you can call it 50% of data, or we can call it the quarter two, and get it by the numpy dot percentile and for the 50. And this line here is the 75% of the data, which is the Q3. And the line here is the 25% of the data, which is the Q1. And we call the range between the Q1 and Q3 the IQR. And we can use the IQR times 1.5 and plus Q3, or use Q1, subtract this to get this bottom line and the top line. And any data above this top line and the bottom line, we call it the outliers. So this is how we develop this box plot. Okay, and then let's move on to the violin plot. So the violin plot, we use the seaborne package violin plot function and put our data inside to get this violin plot. And then let's move on to some overlaid histogram and density curve. So let's check our data again. So this time we want to compare the density function or histogram between the smoker and non-smoker. So to do this, we first split our data into smoker data and non-smoker data by this column equal to true or not. So after we get these two subset of our data, we use this histplot function and put the smoke data and non-smoker data inside, and make the KD equal to true so we can get the line. And we want the density function, not the histogram, so the static density, and give it a label. And then we can see that we In this plot, we have both smoker and non-smoker inside our data and how it influences our the baby's weight. For example, we can see that non-smokers have a higher birth weight than the smoker. The PLT.legend here is to help us generate this square here, so that we know that blue is non-smoker and yellow is smoker. And then we want the side-by-side box plot and violin plots. So to make the side-by-side box plot, we need to use this box plot of the Seaborn package, and the data is equal to our pandas data, and the x is the x-axis, which is here we put this whether there are smoke or not. Put it here, true and false. And the y is the y-axis of the bar plot, which is the birth weight. After that, we have the side-by-side box plot. And we can see that still the non-smoker has a higher baby weight than the smoker. And similarly, we can use the violin plot to present our data and keep other argument the same, just to change the box plot to the violin plot so we can get a violin side-by-side plot. And another way to build a side-by-side box plot is to use the plt.boxplot. And to do that, we first need to get together the value of the smoker and non-smoker, save it in one variable, put it as the first argument of the box plt.boxplot. And the second argument of this box plot is the group name. And then we can see that this is the side-by-side box plot of our data. It did the same thing as this one, but compared to this figure, I think the Seaborn, this figure is more beautiful than this one. And similarly, the PLT can use the violin plot to do the same thing. But still, I think the Seaborn had done a better job. Okay, and then let's move on to the scatter plot. Let's check our data again. And this time we want to find the relationship between the height and weight. So to do this, we use plt.scatter. The first argument is the x-axis, which is the height. And the second argument is the weight, the y-axis. And then this plt.x label and y label simply just records the label of the x-axis and y-axis. And then we can see that this is the scatter plot of our data. And we can also use the Seaborn to do the same thing by the scatter plot function. But at the same time, we can see that in the Seaborn, we can add another argument called the who. The who basically split our, add another category or add another dimension of our data. So this is a smoker data. So it splits our data with these smoker or not. So you can see that all the orange point, they are smoker, and the blue point, they are non-smoker. So that we can clearly see how the smoker information influence the relationship between the height and weight. And similarly, we can, not similarly, we can also fit a regression line to our, for each of our data by this LM plot, which is some linear plot thing. And X is height, Y is weight, say I is false, that means a confidence interval. We don't want to see that. And for the who is the smoker. And you can change the line color you want. So here I change the line color to red. If I don't do this, then the smoker will have an orange line, non-smoker will have a blue line. But you can also change the color to any color you want for the line. Okay, and we run this, we can see that. Let me change this back. Now we can see that if the mother is non-smoker, then the baby's weight is higher. However, the smoke or not don't change the relationship between the height and weight, because you can see that this two line has the same slope. Yeah. And then let's move on to how to use the drawing plot. So basically, drawing plot includes different kind of plot in the same figure. And the default value of the drawing plot is the scatter plot with the histogram. If we execute this, the drawing plot, data is the birth, and the x is the height, y-axis is the weight, and the height and weight. And we can see that in the middle, we see the scatter plot. And then we can also see the histogram of each of these variables. So this part, histogram is the height. This part, the histogram is for the weight. And we can also add this who as another dimension of our data. After that, we can split the scatter plot into smoker and non-smoker. And at the same time, we can also check their KDE line. And we can also change the kind of the drawing plot. So here, if we change the kind to hex, and then we can get a hex plot in the middle. And at the same time, we have the histogram of the height and the weight. So basically, height, the hex plot records how many observations in each of the points. So if this is the dark, then there are more observations here, and if it is lighter, then there are less observations here. We can also use this drawing plot to do this KDE plot. So for two variables, so like you can see here, the kind of KDE, and the fills to true means we fill this with color. So the darker, more observation, the lighter, less observation. If you don't put this field to true, then this is what you will get. There's no color inside. We only records the KDE line for each of these variables with their whether they're smoke or not. And finally, this dot plot can do a lot of things. If we simply put our data and then dot plot, then it will plot all of our columns data. And then let's move on to the second part, which is the O6 level 1 visualization EDA lab. So in this part, we're going to learn how we can use our data to generate some good reports. But for this task, we first need to use these to install some packages, not by import, but actually install it. So to do it, we need to pipe install this master zip from the GitHub. It will take like 20 to 30 seconds to execute. Okay, so after you install this package, you have to go to the runtime and restart runtime. After you restart the runtime, then you can execute the below code to import pandas and get the profile report function. This is what we download here. Get this and get our data in. So this data is the World Happiness 2019. As you can see here, at the head, we have columns and rows, and then we use this profile report to put our data frame in to get the profile. And then we can print our profile. And you can see how powerful it is. And then let's print this profile. So inside of the profile, you can see you can first check the overview of our data. We have 9 number of variables, 156 observations, missing cells, missing cell percent, duplicate rows, total size of memory, different kind of information. And we can check each variable's information, the summary statistic of each variables, and the interaction between each variables, and the correlation. If there's any missing values, some sample. So this whole thing is the report that we generate from this profile report function. And then let me introduce you another powerful tool called the Lux. So still we need to pipe install this Lux. Okay, and similarly, we have to use the runtime and restart runtime. and then execute the following code, import logs and get our data again. And to actually run these logs, we need to use this enable customer wage manager to actually enable these logs. And then we can print our data frame. And by clicking this toggle pandas.logs, we can see this beautiful plots. You can check the correlation of different variable, check the distribution of different variables and some occurrence. And after you get what you want, you need to remember that we need to disable this custom wage manager at the end. Okay, so that's everything we need to learn for today's tutorial. And let me know if you have any questions. Thank you. Let me stop recording.